For nearly a century, humanity has depended on a single narrative to explain everything we observe in the cosmos. It is a story so potent that it has rewritten textbooks, guided generations of scientists, and even earned Nobel Prizes. It is known as the Lambda CDM model, and for decades, it has served as our cosmic operating system. But what if that system is already outdated? What if the universe we thought we understood isn't the universe we are actually living in? Right now, a telescope orbiting 1,000,000 miles from Earth may have just revealed cracks in the foundation of modern cosmology. And these aren't hairline fractures. They are deep chasms. The James Webb Space Telescope is witnessing things no one was prepared for. By looking back in time to the very beginning, it has uncovered objects that simply should not exist. We're talking about impossible structures that break the timeline of the Big Bang. We're going to explore why Nobel Prize winners are quietly confessing that the early universe looks nothing like we assumed, and why some are asking the most radical question of all. Did the universe actually begin the way we think it did? To grasp why everyone is panicking, we first have to understand the tool we have been using for decades. The Lambda CDM model has been the gold standard. It dictates that the universe is dominated by two invisible ingredients: cold dark matter and dark energy. Together, these forces control how the universe expands and how galaxies form. According to this operating system, the early universe was supposed to be a quiet place. It should have been simple, dark, and sparse. It was a time when matter was only just beginning to organize itself. We call this period the Cosmic Dark Ages, a time right after the Big Bang, when no stars or galaxies were supposed to exist yet. But then, we switched on the James Webb Space Telescope. Webb doesn't just look across distance, it looks back in time. Every faint glow it captures started its journey billions of years ago, long before the sun even ignited. And when Webb aimed at these ancient regions, places that should reveal the universe in its infancy, it found something shocking. Instead of darkness, Webb found structure. It found motion. It found immense, luminous objects that were already fully formed. These weren't the small, faint, primitive blobs of gas the models predicted. There were thousands of objects that were too massive, too bright, and too dense. Astronomers stared at the data and repeated the same thing over and over. That's not right. Webb is seeing complex structures where complexity should be mathematically impossible. It is finding objects that appear far too mature for a universe that is only 13.8 billion years old. This isn't a data error. Independent teams across the globe are seeing the exact same thing. The cosmic operating system has crashed. Here is why this is such a nightmare for physicists. The Lambda CDM model has a very strict schedule for how the universe grows. It says that early galaxies develop slowly. They are supposed to pull in matter over vast stretches of time, forming stars gradually, piece by piece. Based on everything we know about dark matter and gravity, there simply isn't enough time or material for massive galaxies to appear just a few 100 million years after the Big Bang. It is like walking into a nursery and finding a fully grown adult wearing a diaper. The timeline collapses. Yet, Webb is seeing galaxies so dense and so large that, mathematically, they would need more matter than the universe could possibly provide at that stage. The numbers don't work. The physics doesn't work. A study published in the Astrophysical Journal identified 87 candidate objects that may have existed just 200 to 400 million years after the Big Bang. To put that in perspective, confirming even a handful of these would be a serious problem for cosmology. One of the researchers, Haojing Yin, put it bluntly: if these objects are real, our understanding of early galaxy formation is fundamentally wrong. We aren't just rewriting a chapter of the textbook. We are realizing the book might be written in the wrong language. As if impossible galaxies weren't enough, the details get even more disturbing. In the universe we know today, the normal universe, galaxies are actually quite inefficient. When a galaxy forms, only about 10% of the available gas is converted into stars. The rest remains as gas floating around to fuel future star formation. It is a slow, steady burn. But the data coming from Webb suggests something radically different for these ancient objects. Some of them appear to have converted 100% of their material into stars. Think about that. No leftovers, no gas left over, nothing to fuel future growth. This kind of efficiency shouldn't be possible, not under any known physical law. This has led scientists to ask uncomfortable questions. Are these even galaxies? Or are we seeing an entirely new class of cosmic object, something that doesn't fit into any existing category? If they are galaxies, the implications are staggering. It would mean the Big Bang model, as we currently understand it, is incomplete, or worse. Maybe the universe evolved faster than our theories allow. Maybe gravity behaves differently at cosmic scales. Or maybe, just maybe, the universe we see is only part of a much larger reality. To understand what might be happening, we have to zoom out and rethink how the universe itself behaves. Back in 1929, Edwin Hubble made a discovery that changed everything. He found that galaxies aren't just scattered randomly. They're all moving away from each other. Space itself is expanding. And here is the strange part. This expansion has no center. Wherever you are in the universe, it looks like everything else is rushing away from you. Every observer sees themselves at the center of the expansion. But it's not just expanding, it's accelerating. The farther away a galaxy is, the faster it moves away from us. Eventually, you reach a boundary where galaxies are receding at the speed of light. This boundary is called the Hubble sphere. Beyond the Hubble sphere, galaxies are moving away faster than light itself. Now, that sounds impossible, but nothing is breaking Einstein's speed limit. It is space that is stretching, carrying the galaxies along with it. Because the universe keeps expanding, the Hubble sphere grows over time. This means light from some galaxies that were once racing away faster than light can still reach us. Their photons are climbing a cosmic escalator that is getting longer as they move. However, there's a hard limit, a final boundary. That boundary defines the observable universe, a vast bubble about 92 billion light-years across. Anything beyond it is forever hidden. The most distant galaxy we've ever detected, Jade's GS Z14-0, comes from a time when the universe was only 290 million years old. But here is the twist. That galaxy is no longer observable today. It has already slipped beyond our horizon. Whatever it has become, we will never know. The observable universe isn't the whole universe. It is just our local window. If the universe is infinite, and evidence increasingly suggests it is, then the Big Bang didn't happen at a single point. It happened everywhere all at once. And that means somewhere far beyond our horizon, entire regions of space exist that we will never see and never influence. But Webb might be catching a glimpse of something that hints at what lies beyond. To really grasp why these impossible galaxies are breaking our models, we need to correct a massive misunderstanding about the Big Bang itself. Most people imagine an explosion at a single point with matter spreading outward into empty space. But that is wrong. If the universe is infinite, then it was always infinite. The Big Bang didn't happen at a single location. It happened throughout all of space simultaneously. Matter didn't emerge in one spot and spread outward. It appeared everywhere at once. This helps explain the cosmic microwave background, CMB, that faint afterglow we see in every direction. It is the light of that event reaching us from all sides. But here is the problem Webb has introduced. If the Big Bang happened everywhere and the universe was supposed to be a hot, uniform soup cooling down, then gravity should have needed hundreds of millions of years to pull that soup into the first clumps. Instead, Webb is seeing structure where there should only be soup. It is like baking a cake and opening the oven 1 minute later to find it already decorated with icing. It suggests that maybe the ingredients were already organized before the oven even turned on. This isn't just a few YouTubers making wild guesses. The panic is happening at the highest levels of academia. Some of the most respected physicists alive, yes, including Nobel Prize winners, are quietly admitting something extraordinary. They're looking at the data from independent teams across the world and realizing the early universe may not have looked anything like we assumed. For decades, suggesting that the Big Bang wasn't the absolute beginning was career suicide. It was fringe science. But the Webb data is so disruptive that scientists are now entertaining ideas that were once considered taboo. They're considering a far more radical possibility. What if the universe didn't begin the way we think it did? What if those distant objects aren't early galaxies at all? What if they belong to something else entirely? This leads us to the most mind-bending theory currently gaining traction: cyclic universes. The idea is simple but terrifying. What if our Big Bang wasn't a beginning but a bounce? What if our universe is just one in an infinite chain of universes expanding and collapsing or fading over and over again? Some physicists are looking at these impossible bright objects found by Webb and asking if they could be remnants. Could they be structures that predate the Big Bang itself? Imagine a previous cosmic epoch that ended, leaving behind seeds, supermassive black holes, or density knots that survive the transition. When our Big Bang occurred, these seeds instantly jump-started galaxy formation. This would explain why we see massive, fully formed monsters just 200 million years into our timeline. They didn't grow from scratch. They had a head start. They are ghosts from a previous reality. If that doesn't sound crazy enough, there is one more possibility that is being taken seriously. One Nobel Prize-winning physicist has openly suggested that Webb may have found evidence pointing beyond our universe entirely. Remember, the observable universe is just our local bubble. If these early objects are too big and too fast for the laws of physics inside our bubble, maybe they're being influenced by something outside of it. Maybe the universe we see is only part of a much larger reality. Just as a fish in a bowl can see shadows moving outside the glass, Webb might be detecting the gravitational influence of structures that exist beyond our cosmic horizon. It suggests that what we call the universe might just be a tiny patch in an infinite, timeless fabric. If we step back from a multiverse for a second and look at the hard physics, the situation is actually worse for the standard model. It is not just about when these galaxies formed, but how. In the universe we understand, the one governed by standard thermodynamics, making a star is messy. It is inefficient. In normal galaxies like our Milky Way, you have a lot of gas, but only about 10% of that available gas actually collapses to form stars. The rest gets blown away by radiation or remains as loose fuel. But Webb is looking at these ancient monsters and seeing something that defies logic. The data suggests that some of these early objects converted 100% of their material into stars. This is the efficiency nightmare. Imagine pouring a gallon of gas into a car and getting 1,000,000 miles of range with zero heat loss. It shouldn't be possible. There are no leftovers in these galaxies. No gas. Nothing to fuel future growth. If this data holds up, it means the fundamental laws of how matter collapses under gravity, laws we thought were universal, might not apply in the early universe. This brings us to option 2 that physicists are whispering about. If the timeline is impossible and the efficiency is impossible, then maybe the force driving them is wrong. The lambda CDM model relies on dark matter to act as the glue that pulls galaxies together slowly. But Webb is seeing things happen too fast for that glue to work. So scientists are forced to ask, what if gravity itself behaves differently at cosmic scales? We assume gravity is a constant. We assume it works the same way today as it did 13 billion years ago. But what if it doesn't? What if gravity in the infant universe was stronger or operated under different rules that accelerated structure formation? It sounds like science fiction, but if you change the strength of gravity in your equations, suddenly those impossible, massive galaxies become possible. The catch? You have to throw away Einstein's general relativity as the complete picture of the universe. You have to admit that our cosmic operating system is missing a massive patch update. This leads to the unsettling realization that the Big Bang model, as we currently understand it, is incomplete or worse. We have been building a house on a foundation we thought was solid rock, but Webb is showing us it might be sand. If the physics doesn't work and the numbers don't work, then we aren't just missing a planet or a star. We are missing a fundamental mechanism of reality. Some researchers are bluntly stating that our understanding of early galaxy formation is fundamentally wrong. We are seeing a universe that evolved faster than our theories allow. It forces us to confront the fact that the observable universe, that bubble we can see, is not the whole universe. We're trying to deduce the rules of an infinite ocean by only studying a cup of water. To understand how big of a deal this is, we have to remember that we have been here before. Before 1929, the smartest people on Earth thought the universe was static and unchanging. Then Edwin Hubble proved it was expanding. That one discovery shattered physics and rewrote every textbook. Now, history is repeating itself. The idea of an expanding universe sounded extreme until it was proven true. Today, the idea that our physics is broken or that there are structures predating the Big Bang sounds extreme. But the data doesn't care about our feelings or our Nobel Prizes. We don't have answers right now, only data. And the data from Webb is screaming that the universe is not finished surprising us. We are standing on the edge of another 1929 moment. So what happens next? If Webb has already broken physics just by glancing at the early universe, what happens when it really stares? The telescope is currently being pushed to its absolute limits. Astronomers are now targeting the specific epoch known as the Cosmic Dark Ages, that mysterious period right after the Big Bang, when no stars were supposed to exist yet. The goal is terrifyingly simple: to find the 0 point. If we look back 200 million years and see monsters, we have to look back further. We have to look back to 100 million years, to 50 million. Webb is hunting for the moment where the impossible stops and the normal begins. But here is the fear keeping scientists up at night. What if it doesn't stop? If Webb peers into the absolute infancy of the cosmos, the moment the universe was supposed to be nothing but hot soup, and still finds organized, massive structures, then there is no patch for the model. There is no fixing gravity. It would prove that the structure of our universe was inherited from something before the Big Bang. It would mean we are living in a recycled cosmos. We are currently in a data war. We don't have final answers, only accumulating data. But that is about to change. In the coming months and years, Webb will move from just finding these objects to chemically dissecting them. It will tell us what they are made of. Are they actual galaxies made of stars? Or are we seeing that entirely new class of cosmic object that physicists suspect? Maybe they are dark stars, monsters powered by dark matter instead of nuclear fusion. Maybe they are the seeds of a previous universe. One thing is increasingly clear: the story we have been telling ourselves about the cosmos may only be the beginning. The universe is not finished surprising us. The Webb telescope has turned the lights on in a dark room, and we are realizing we don't recognize the furniture. And as it continues to peer deeper into space and further back in time, we might find that the universe isn't just stranger than we supposed. It's stranger than we can suppose. So what does this leave us? For 100 years, we thought we had the map of the universe. We thought we knew how the story began and how it would end. But the James Webb Space Telescope has just reminded us of the most important rule in science. The map is not the territory. Right now, we don't have all the answers. We only have data, and the data is telling us that the universe is not finished surprising us. Whether these objects are impossible galaxies, dark stars, or relics from a time before time, they are proving that the story we have been telling ourselves about the cosmos may only be the beginning. The universe just got a lot more interesting. If you want to stay on the front lines of this scientific revolution and see what Webb discovers next, make sure to hit that subscribe button and turn on notifications. Because if physics is broken, we're going to need everyone to help fix it. Thanks for watching, and keep looking up. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.